Welcome to the second seminar in our series. In this talk, we'll be discussing the research process. Please see the video description for a full list of disclaimers, including the ones here, plus a timeline and helpful resources and links. Please support the channel by using our affiliate links. The first thing we'll consider is a problem statement or research question or questions or an hypothesis. And these are all different ways of organizing the research and providing some direction for the research. If there isn't a question or a problem statement or a hypothesis that guides the research, it's possible to end up with a purely descriptive study and document, and that doesn't make a very strong master's thesis and definitely not a PhD dissertation. So my suggestion is to state the problem briefly, ask research questions. What are you hoping to learn? And you might also put your problem in terms of a hypothesis. What do you think you will find, or what perhaps you hope you will find? And then the research should be directed towards solving the problem, answering the questions, or testing the hypothesis, either providing evidence in favor of it or against it. Here are some examples of a problem statement, research questions, and hypothesis. And these could be more specific. They would probably be elaborated on in subsequent text. But for example, a problem could be stated as: we seek to design a compact antenna that has extremely wide instantaneous bandwidth. And you could certainly go into more detail and would need to about what constitutes a compact antenna. How small does it need to be? How wide band does it need to be? How instantaneous does that bandwidth need to be? Are there specifications related to time dispersion? So these are all questions that need to be answered to have that definition of the problem that will guide the research. You could also ask questions on a similar topic. Then we could ask, can a conventional antenna design be optimized to provide the desired performance? Or perhaps could a specific type or class of antenna be optimized? Or can a new type of antenna be identified that meets the desired performance specifications? Or if we're going to phrase this in terms of a hypothesis, we might hypothesize that a particular design or design procedure can produce antennas that meet a certain specification. And in this case, we might further constrain that to use commodity materials rather than specialized or expensive materials. After the research topic has been defined, a literature review is an essential part of the research. By reviewing technical literature such as journal articles, conference papers, theses, dissertations, and reports, you can get a clearer picture of the problem and the current state of research, so that will provide a context for your own work. And it can help you identify a problem to study or refine your problem statement, research questions, and hypothesis. The research that you'll do in a literature review consists of finding, reading, summarizing, and analyzing research on a particular topic of interest. You'll identify relevant and important papers, journals, conferences, and also researchers who are active in the area. And you can go back to those conferences, journals, and researchers to find more and additional research on this topic and related topics. To make the literature review time efficient, you want to read papers efficiently to decide whether they are relevant, and if you do decide that they're of interest for the literature review, you want to be able to understand them as quickly as possible. A literature review should do more than just report literature and research that's already been conducted. You'll not only summarize the papers that you've read, but also classify them according to major themes, summarize their goals, methods, results, etc. You'll want to identify any conflicting results or missing areas of research, and that will give you ideas for your own research, as well as potential future research by others. Once you have a topic and an understanding of the background and the current state of research in that area, you'll need to select a methodology or an approach to answer the questions that you've set out for yourself, or to address the problem that you've defined. Questions you might ask are, how do I think I can solve the problem? What methods will enable me to answer the questions? How can I test the hypothesis? Also, if you're not yet familiar with the methods that you think you'll need, what resources are available to help you learn them? And if learning the methods is something beyond the amount of time that you have available, how would you proceed then? If the topic is interesting but too far out of scope for your current preparation, you may want to defer it till later and perhaps work on it in collaboration with other researchers who have some of the skills that are needed to answer the problem. You could do that even during your graduate studies. However, your thesis or dissertation will need to clearly indicate your own individual contributions, and those contributions must be substantial enough to meet the requirements of the thesis or dissertation in your field. Different approaches you might use to address a research problem include analysis, simulation, experimentation, or observation. An analytical approach involves setting up the problem in a way that can be modeled mathematically. This may require some simplifying assumptions, but the advantage of this approach is that it can provide insight into the effects of various parameters. You'll end up with one or more equations that describe the problem or the phenomenon that you're studying, and you can analyze those to see the effects of different parameters and to identify trends that you can expect. It may be possible to achieve a greater level of realism through simulation. You may be able to simulate things that are too complex to analyze. Also, you may be able to simulate more cases than you could realistically study through experimentation. So simulation is perhaps the next step towards realism, while less tractable than analysis. Experimentation is the most realistic and therefore very convincing, especially if the results are consistent with the theory and simulation. If they're not, then it's necessary to check and see what might be leading to those inconsistent results. In addition to experimentation, in which controlled cases are considered, observation may be an option, and in some cases it may be the only option. We could think of an example of an electrical grid failure. That isn't something that you want to reproduce in an experiment, but if you happen to have data from such an event or events, you can analyze those. Whatever approach you take, you'll have to analyze the data and present it in some way that others can understand and interpret it. Theoretical analysis will provide the most direct results in the form of equations that can provide insight into the role of various parameters, as I mentioned before. However, a graphical presentation of specific cases may be valuable, and in fact that may be a good way to demonstrate the effects that you've identified through inspecting the equations. Simulations, experiments, and observations produce data that must be processed, often using statistical methods. They can be presented in a variety of forms. Results can be presented in a variety of forms, including graphs and tables and perhaps interactive visualization. While data can be presented in tables, in many cases graphs will be easier for the audience to interpret. So you need to consider the amount of work that it will take you to present the data, yes, but a primary consideration should be the reader's ability to understand the information quickly. And anything you can do to help them do that will make it easier for other people to use the results of your research in their own research. And this will be reflected in citations of your publications, but also, and more importantly, you'll have the satisfaction of knowing that other people are using your work for productive purposes of their own. Statistical methods can be used to help check assumptions and quantify uncertainty in results and test hypotheses based on data. Another consideration is replication or reproduction of results. If others can reproduce the work you've done or redo the analysis and get similar results, that increases the confidence in the results that you've obtained. You can make this easier for other people to do by documenting your work thoroughly, and there are tools to facilitate this that allow creation of documents that include data, code for analysis, and a description of the experiments or simulations and the analysis and presentation of results, all within a single integrated document. Once you've identified a research problem and a methodology and performed the research and found a way to present the results, the next step is to publish these results so that others can see them and use them. This can be done by simply posting results on a website, and sometimes unpublished papers or preprints are made available. If you're considering those as part of your literature review, keep in mind that they haven't been reviewed by other researchers, so there's less quality assurance than you might find with a technical conference paper or journal article, because conferences and journals typically use peer review in which other experts, other than the authors, review the work, and while they may not reproduce the research, they'll at least check the papers for internal consistency and identify any obvious flaws. So that's a level of quality control that exists in those types of publication. While it's common practice to post preprints on the web, self-publishing or announcing highly unusual or controversial results before going through a rigorous peer review is risky, and there was an example of that in 1989 with a phenomenon that was called cold fusion, and some researchers believed that they had observed nuclear fusion at room temperature and did not want to wait for the peer review process for various reasons, so they announced this publicly, and the news media interpreted this as a source of unlimited cheap energy, and there were very high expectations for a while, but it turned out that other researchers were not able to duplicate the results. Some thought that there might be some phenomenon, but it turned out that no one was really able to duplicate the results, and some other researchers identified potential sources of error in the original experiment. So this created an embarrassing situation for the researchers who had made the announcement, and is just the kind of thing to keep in mind, as if you think you've discovered something very unusual, you may want to be cautious in how you announce that. This is a diagram of the research process in the context of graduate school, where you would find a research advisor, a topic, begin the research, get ideas, more specific ideas for the research, and proceed using good research practices. Now, there's certainly a lot more detail that goes into a successful thesis or dissertation, but this is the general process. And from the same source, we have some thoughts on ideal characteristics of a research advisor, and these include research interests in common with the student. So you would want to have an advisor who is at least working in the same general area of your field that you want to consider in your own research. Ideally, they'd have a very good reputation among researchers, grant support for research. If you want to be supported on an assistantship, the funds would typically come from external sources, such as grants. An advisor who has successfully advised students in the past, that's a good indication for you as a new student working with the advisor. And the reputation of the advisor for working with the students, their likelihood of staying at the university, that's something you can talk with the person about, and reputation among the students. And then having an active research group is an advantage too, because you'll have other students that you can talk with and exchange ideas, and you'll be learning from them as well as from the advisor and from the courses that you take. To get ideas for your research, you can become an active reader and listener. Reading research in your field to get ideas even beyond your initial literature review can be very helpful. Listening to seminars, conference presentations, a wide variety of information that's available on the internet, and just listening to your colleagues, the other students you work with, as well as the faculty, can give you many ideas on particular topics relevant to your research, ideas on how to conduct and present research in general. All of these can be gained in that way. You can look into a particular topic in the context of an independent study. You can work with a faculty member to design a specialized course that will be something that you would do during a semester, typically for a few hours of course credit. That should be arranged before the semester in which you plan to take the class. Of course, you'll need to formulate the research problem. While you do need to have a literature review, that needs to be constrained so that you have some time to develop your own ideas and choose one idea that you can focus your thesis or dissertation on. And even after you've done that, again, stay active in reading journals and conference papers. Ideally, the purpose of your research should be clearly defined, as we talked about. Having a problem statement or research questions or hypothesis will help do this. Also, as we mentioned earlier, you need to describe your research in sufficient detail that others could repeat it if if they chose to, and plan the research in a way that will yield results as objective as possible. If there are limitations in the methodology that you've used, or limitations that are inherent because of fundamental limitations of physics and so forth, you need to report these and also estimate how they may affect the results. Also, it's desirable to check data. If you see anything highly unusual, consider whether it's really valid data. Statistical methods can be useful at this stage, and analyze the data in a way that's appropriate to reveal significance of the data. This is a general outline or format for a journal article, conference paper, report, thesis, or dissertation. It isn't anything extremely original, but it's worth considering. These are general components that will be part of any such paper. In the case of a thesis or a dissertation or a report, there will be a title page and perhaps some front matter like a table of contents, perhaps dedication, acknowledgments, things like that, as well as the table of contents. There would typically be a list of figures, a list of equations, a list of abbreviations and acronyms that will help people either find important information in the document or understand what terminology means that is used within the document. Both a longer report or thesis or dissertation and an article or conference paper, all of those publications would typically have an abstract. An abstract is a summary of the research. It isn't really the same as an introduction, but it will have some of the information that's in the introduction and the conclusions, as well as a brief description of the methodology, all in a very condensed form. These are often just a few hundred words, maybe 100 to a few hundred words. After the abstract, you'll have an introduction that identifies what the problem is and why it's important, and then briefly indicates how the rest of the publication is organized. After reading the abstract, though, a reader should be able to determine whether the paper is of interest to them and whether they need to read the rest of it. The background section will provide context for your work. That's where the literature review goes, or much of the information from the literature review that will establish the state of research in the area and how your research contribution fits into that. You'll need to describe the methods or approach that you used to address the problem, and there would typically be a section of the paper or a chapter or chapters in a thesis or dissertation that describe that. Of course, you'll have results. You need to present those results and discuss them, interpret them, discuss their significance, and then describe or state your conclusions and identify any future work that you think is necessary based on the results that you've obtained. Finally, you'll list references, the sources that you used in your research. So that would include the prior research in the area that you've identified in the literature review. It would include papers that provide more in-depth description of the methods and approach that you used, and any other sources that you used to write your paper. There are ethical considerations in research. We won't go into them in detail here because there are other sources available, including online training. Just refer to that at the bottom of the page. But we need to consider things like proper use of references. That's the most pervasive. You may be working with sponsors who have restrictions on what you're allowed to publish or processes for getting approval for a publication, so you need to consider that. Intellectual property may come into play. And then in some cases, if there are human research participants who are not the researchers themselves, you may have to consider confidentiality or anonymity and go through an institutional review board. This is typically necessary for survey research or interviews or anything like that, and needs to be done before the research is conducted. Once you have that approval, then you'll have guidelines for how to conduct the research, and you'll have approval to publish it. You may need to consider conflict of interest in some cases, perhaps not directly as part of your research itself, but perhaps as part of your employment. These are some of the references that we've been using in this series. The first one is the source for many of the slides in this particular presentation. And here's a suggested assignment before the next session, and that is to find and download a thesis or dissertation on a topic of interest to you. It doesn't have to be on a topic you're interested in, but it might as well be, so that it can be part of the literature review process for your own research. And once you've found that, and these documents are widely available online, I'm asking you to outline the document, and you can do that based on the chapter titles, so you could refer to the table of contents. This whole exercise shouldn't take very long, but what I'd like you to do then is compare the structure of the document to the outline that we just looked at, and see how how one maps to the other. And it should take this whole exercise should take maybe a half hour, maybe a little more, maybe a little less, but in well under 5 minutes, you should be able to give a presentation that compares the structure of these two. Thanks for your time. Please hit like and subscribe and support the channel by using our affiliate link if you plan to buy a featured item. We also provide consulting services and referrals.